Good day, sir. We are EROTORS and we are here today to discuss about solar power home grid tied time. So this video presentation has two parts. The first one is the parts and function of solar powered home, and the second one is solar powered home grid tied on design. So let's proceed. So for the first part, let's discuss about the solar panel. So solar panel has two types. This one, the original or the classic blue one, which is we call polycrystalline solar panel. Polycrystalline yung solar cell niya, then monocrystalline silicon ingot, yung kanyang yung pinaka nasa loob ng kanyang solar cell. Then we have the monocrystalline. So ang pinagkaiba nilang dalawa bukod sa kulay is the polycrystalline is yung pinaka ginagamit sa market natin when someone is trying to create a renewable source of energy, basically para sa kanilang mga bahay. So bukod sa pinagkaiba nila, si polycrystalline is mas maliit yung lifespan kaysa kay monocrystalline, which is si polycrystalline lasted about 25 to 35 years, while si monocrystalline lasted 25 to 45 years. Then kung sa performance, is mas malaki din yung agwat nila kasi si monocrystalline is kaya niyang mag-produce ng mas efficient na energy source lalo sa sobrang init na surroundings. Okay. Now, let's proceed to the inverter. So, si inverter, basically, yung responsible sa paglilipat or sa pag-convert ng direct current from the solar na magagather natin sa sun, which is direct current to AC or alternating current para i-supply sa ating mga bahay. So, dito, as you can see, meron tayong dalawang model ng inverter. So this one, yung may orange is parang ito yung pinaka-common na nakikita natin, which is to, sabi nga niyo po sir, is pang medyo mamayaman. So
here we have the DC surge protection device. The DC surge protection device is placed parallel to the DC circuit breaker. It generally protects the system from power surge and redirects the excess power to the ground. The system from power surge, or as we call it, a transient voltage. And transient voltage is defined as the sudden spike in voltage that only lasts for about tens to hundreds of a second. Most of these transient voltage are directly or indirectly caused by lightning. So to put it into perspective, a tenth of a second is 0.1 seconds and hundredth of a second is 0.01. And being high up and exposed to the environment, a grid-tied system is no different from a rod or a lightning rod. This makes it vulnerable to lightning, though the surge protection device can only protect the system from indirect lightning strikes. Multiple interconnection within power cables are very susceptible to electromagnetically induced transients, where power surge could also arise. Exposure to these transient voltage may cause a catastrophic component damage, leading to system failure. So, to summarize, a surge protection device is an essential component to a grid-tied system because of the safety it offers for both the owner and the system. Next, we have the AC surge protection device. The AC surge protection device is placed parallel to the AC circuit breaker. Similar to the DC surge protection device, this serves as a protection from transient voltage for the AC side of the grid-tied system. It redirects the excess energy to the ground. Multiple internal or external connections on the grid can cause electrical anomalies where power surge can occur. So An AC surge protection device offers the same level of safety as the DC surge protection device. The only difference is that it should be connected to the AC side of the grid tie system in order to work. Next, we have the AC circuit breaker RCBO type. So RCBO stands for residual current operated circuit breaker with overcurrent protection. These AC type RCBO circuit breakers are ensured for alternating currents only, whether they are quickly applied or slowly increased. It monitors electrical circuits to keep them running safely and disconnects the circuit if it is unbalanced. So what sets this apart from our typical circuit breakers? The RCBO type circuit breakers has an added protection that if it senses earth leakage or if somebody touches a live wire, it automatically trips to avoid casualties. And if budget allows it, RCBO is the recommended component for a customer safety. In addition, it can also be manually switched off if needed. Next, we have a time delay switch, or also called the power on delay. It prevents any electronic device from switching on for a desired time interval. So, in an event of a blackout, there's a tendency of a power surge after power is restored. A time delay switch prevents this by delaying the switching on of a system for a minute or so. This is not only to prevent problems caused by blackouts. The grid tie systems are constantly switched on and off, and having a time delay switch prevents incoming surge as opposed to having it instantly switched on. Next, we have a similar component, the programmable timer switch. Turning the grid tied system on and off is a vital routine, which cannot be perfectly done on a daily basis. Discernible by its LED screen, or LED screen rather. Programmable timer is a hassle-free component that automatically switches the system on and off at your desired time. So just like the time delay switch, except this one can be programmed by the user. So let's say the owner is too busy with work. Sooner or later, they'll forget their routine involving the grid tied system. That being said, a programmable timer switch gives the owner the ability to switch the grid tie system on at the exact time of sunrise and switch it off at exactly sunset. So no energy is wasted in an event that the owner forgets to turn it on or off. Net metering. Net metering is an electric billing tool that uses the electric grid to store excess energy produced by your solar panel systems. Under net metering, the unused energy your solar panels produce is credited back to you. Okay, so in net metering, in some cases, owners notice an increase in their electricity bills even after installing the solar power system. And it happens because grid-tied systems may produce more energy than required in a day. Given that this energy will pass through the meter, this supposedly free energy will be billed to the owner without net metering. In order to prevent cases like this, the one I mentioned earlier, applying for net metering is highly suggested. Now, the question is net metering available in the Philippines? And the answer to that is yes. In the Philippines, 100 kilowatt solar panel systems are allowed to connect to the grid under the net metering program. The Energy Regulatory Commission's Renewable Energy Act of 2008 aims to encourage users to participate in the generation of renewable energy. And when renewable energy is mentioned, this also includes the likes of geothermal, wind, tidal, and etc. In other words, net metering is applicable to all renewable energies. It's just solar powered is the most common in the Philippines. Next, other than safety and avoiding fluctuations, one benefit of net metering is that it credits the excess energy exported to the grid into your bill, which generates savings. This can also be a protection from future increase in electricity costs. So on top of all this, it also uh, reduces the amount of electricity that we buy from local distribution utilities or DU. Okay. The DU may opt to install two unidirectional meters, one to meter energy you buy from the local DU and the other to meter the energy you export to the DU. Now, why is this important? Because distribution utilities need to monitor the they need to monitor which energy is produced by the grid and which is produced by our grid types are most commonly used because it's more economical. The single bidirectional meter can meter both import and export energy. But either way, the meters mentioned will replace the current meter you have once you apply for net metering. Okay, next. Who are applicable in for applying for net metering? All end users are in good credit standing in the payment of their electric bills to the distribution utility are qualified to the are qualified to participate in the net metering program for renewable energy. The good credit standing was further clarified as the end users with no unsettled or outstanding obligations with the distribution utility at the time of application. So, simply put, as long as you are a customer of the DU without unpaid fees, you're eligible for the net metering program. Next, what if the customer doesn't want to apply for net metering? Because some owners doesn't have the time or patience to apply for net metering, and these are possible consequences or other ways to prevent additional fees being applied to you. Even if you do not export electricity to the grid, your connection may still pose risk to linemen performing maintenance, your household appliances, and neighboring houses connected to your circuit. If not applied for net metering, the excess energy will be billed to the customer. If the system is rated at 5 kilowatts, for example, and the load consumption is 4 kilowatts, the excess 1 kilowatt will be sent to the grid, passing the meter and billed back to the customer. So even without applying, the same effect can be achieved by using an inverter with limiter. So this limiter is important in cutting costs without the help of net metering. Using a limiter, one can monitor the power load, and on top of that, they can also save the excess power going back to the grid. Now, how do these components connect? Which components are optional in a grid tie system because there are so many, and possibly some of these are just optional just to cut costs. Here we have a example circuit connection. This first one is the cheapest possible connection for a grid-tied setup. Still, this connection is acceptable and follows the standards of PEC or professional engineering consultant. Okay, so as we can see, a circuit breaker and a surge protection device should be present on both the AC and DC side of the system. And an important note, connection differs with the distribution utilities. It can either be line to line where both wires are live wires and have a 110 and 115 volts, or line to neutral, where only one wire is live with 220 or 230 volts. But what difference does it make? In a line-to-line connection, the black and red wires as seen here can afford being switched. But on a line-to-neutral connection, the black and red wire must not be switched in order to avoid damaging the circuit. And notice that the circuit has an inverter but is missing a limiter. So meaning this circuit needs to apply for net metering. And on the next slide, you have a more complete connection. Okay. So we see more components in the circuit with the additional of time delay switches, both manual and programmable, and a limiter. Starting with the solar panel, the wires must be connected to the positive and negative of the DC circuit breaker. Now, the circuit breaker is then connected in parallel to the DC surge protection device, which is then connected to the ground. On the AC side of the circuit, the spare circuit breaker inside the panel board must be connected to the input of the RCBO, which is what we have right here. Keeping in mind which type of connection we have, because again, line to line and line to neutral, these black and red wires cannot be switched if we have a line to neutral connection. Then the output of the RCBO must be connected to the input of the AC surge protection device, which is again connected to the ground. This green line here is the ground. For the optional time delay switch, its input must be connected in parallel to the input of the AC surge protection device. Under the optional components, the programmable timer switch, which must be connected to the time delay switch, and the AC out of the inverter, which is also connected to the ground. Now, regarding the limiter, if the connection is line to line, it can be connected on either
Electric wires. Alam naman natin yung electric wires is important to function our electricity, especially for our solar powered home. Then, for solar powered home, meron tayong different types of wire na maaari nating magamit. And it's according to kanilang pagkakasunod-sunod. Then first is TW, which means thermoplastic wire, moisture resistant, and flame retardant. Ibig sabihin yung TW is moisture resistant or hindi nagmo-moist yung wire. Then yung thermoplastic then is flame retardant o hindi madaling masunog. Ito yung picture ng TW. Then next is THW. From number 1, TW, nag-add lang ng age or pwede natin siyang tawagin na yung age na yan is heat resistant. From number 2, mas gumanda na yung wire or mas maganda siya sa number 1 na TW. Kasi ito ay thermoplastic heat resistant wire or hindi madaling or hindi kagad umiinit yung wire na to. Next is THHN. From THHN, ito is thermoplastic high heat resistant nylon coated. Designed for specific insulation material, temperature, rating, and condition of use suitable for dry and damp location. Yung THHN is meron siyang insulator. Yung insulator na yan nakakatulong para maiwasan yung pagkasira ng nakabalot na wire. ito yung nagiging protection para hindi masira yung wire. Then next is THHN/THW-2. Yung THHN/THWN-2 is combination ng two wire. Yung wire na yon, yung THWN, yung W na yon is water resistant. Then yung THWN is rated for up to 167 degree Fahrenheit or 75 degrees Celsius. Then yung THWN naman is rated for 90 degrees Celsius. Then ito yung recommended at pinakamaganda sa tatlong nauna na type ng wire. Then kung gusto niyo na mas maganda yung setup ng mga wires ng solar power home nyo, maaari nyong gamitin yung PV wires. Yung PV wires, this type is an exclusive kind of wire created by PV applications. These cables behave extremely well in very hot temperatures and other harsh environment conditions. It's especially characteristic compared to the other wire is its consolation and outer sheet, which is made of XLPE or EPR. Yung XLPE is acronym for across-linked polyethylene, and XLPE is a thermosetting polymer, meaning that the material is cured under heat and in that process form bond in all direction, forming a three-dimensional matrix. EPR means ethylene propylene rubber. Yung PV wires is pinakamaganda pero siya rin yung pinakamahal na wires. Kaya kung bibili ka na lang ng wires at may budget ka maganda, ito na yung bilhin mo. Then kung nagtitipid ka, recommended na yung ito nga pala yung feature ng PV wires. Then kung nagtitipid ka, mas recommended na yung THHN/THWN-2. Next is yung solar powered home, yung AWG, which means American wire gauge. For American wire gauge naman, imbis na mataas, kung mataas yung wire mo, number ng wire, ibig sabihin, manipis yung wire na nakapaloob dito. Then, kung mababa naman yung number ng wire mo, nangangahulugan lang na mas makapal yung wire na yun. Then we have computation table for wire sizing. Ito yung mga gagamitin natin. And we have steps in PV system conductor sizing. Itong paraan para ma-compute natin yung wire size natin gagamitin. First is look for the ISC rating of PVC cells. Number 2, multiply by 2 safety factors, irradiance and continuous duty. Number 3 refers on table 310.15 B16 for the size of wire. Number 4 refers on table 310.15 B2A for ampacity correction due to ambient temperature more than 30 degrees Celsius. Number 5 refers table 310.15 B3C for ambient temperature adjustment due to conduit or wire distance from the roof. Number 6 refers on table 310.15 B3A for adjustment due to more than 3 wires inside a conduit. Number 7, the adjustment due to voltage drop. Number 8, the value obtained in the last step will be the basis for the size of wire to be when necessary. Note, means when necessary. Then yung step na to, hindi naman sinasabi na or wala namang exact rule na nagsasabing ito yung recommended computation. Or pwede ka naman rin gumamit ng mas matabang wire kung saan mas maganda yung flow ng current. Then, we have sample problems in PV system conductor sizing. Find the proper wire size for a grid-tied PV system consisting of 3 GA solar panels connected in series with specs at the previous slides. Then, gagamitin natin yung GA solar panels kung saan gagamitin natin yung series. Then, step 1, look for ISC rating of PVC cells. Yung ISC, ito yung short circuit current. Since series yung ginamit natin, hindi magbabago yung current niya. 9.75 pa rin based on its spec. Ito siya, short circuit current ISC, 9.75 amperes or equals siya sa IPV. Then, step 2, multiply by 2 factors by irradiance and continuous duty. Yung irradiance, ito yung excess sun rays, and the continuous duty naman, ito yung 3 hours or more services of ng service ng ating solar power system. Then, sa equation na ito, magiging bago na yung IPV natin. Times natin yung 9.75 amperes times 1.25. Ito yung 125%. Times natin sa 1.25 is equals to 15.23. Next step is refer on table 310.15 B16 for the size of wire. The table indicates number 14 with an ampacity of 25 amperes. Tingnan natin sa table. Sa table, gagamitin natin yung copper. Then, yung wire naman natin gagamitin is THN/THWN+2. Then, pasok siya sa 90 degrees. Then yung ano natin, ampere natin is, yung current natin is 15.23. Then, pasok naman siya sa number 14 na AWG. Next is, since number 14 AWG is not the best practice for PV system, use number 12 THHN with an ampacity of 30 ampere. Find the proper wire size for a grid-tied PV system consisting of 3 GA solar panels connected in series with specs at the next slides. Step 4, ampacity correction due to ambient temperature. Since yung temperature sa atin, based on the table, is nakabase lang siya sa 30 degree ambience. Yung sa Pilipinas is ranging 37 degree. Kailangan pa nating i-convert or i-correct yung ating ampere. We have from ranging 37, happy natin, 36 to 40, pasok siya sa 36 to 40. Then yung 90 degree Celsius is 0.91. Kaya times natin siya sa 30. 30 times 0.91 is 27 ampere. Step 5, ambient temperature adjustment due to roof wire distance. Dahil yung pag nakadikit yung wire, yung solar panel natin sa bubong, maaaring mag-cause pa or madagdagan pa yung heat or madagdagan yung Celsius ng ating solar panel. Kaya mag-a-adjust tayo ng 1/2 inches. Kaya yung panibagong temperature natin, magdadagdag tayo ng 22 Celsius. Degree Celsius. Pa-plus natin siya sa 37 na ambient sa Philippines. Kaya meron tayong 59 degrees Celsius. Since 19.71 amperes is greater than 15.23 amperes, our selected is number 12 wire will fit the system. Then since yung amperes natin is greater than 15.23, gagamitin natin yung number 12 na wire for our solar panel. Step 6, since there's only 2 wires inside the conduit, this step can now be passed dahil dalawa lang yung wires na gagamitin natin, hindi higit sa 3. Then step 3, adjustment due to voltage drop. BD or voltage drop. Meron tayong formula na gagamitin. Voltage drop is equals to 2 IR, or value ng R is equals to K constant length divide area. Then equals to 2, we have to sign 2 times natin sa 9.3. Yung 9.3 na ito yung ating maximum power current. Then yung K, yung 12.9, ito yung constant na K. Times natin sa length ng ating wire. Sample natin yung 25. Then yung area gagamitin natin is circular mill. Then yung size ng AWG natin is 12. Kaya meron tayong 6,530. Then equals to 0.92 volts. Then divide natin sa maximum power voltage niya na 32.26. Then times natin sa 100. Kaya ang lalabas is 2.85%. Since 2.85% is less than 3%, our selected number 12 wire will fit in the system. Then since malapit na siya sa 3, gamitin natin ngayon yung number 10. So number 10, but since 2.85 is bit near to 3, it would be better to use number 10 THHN wire for additional safety factors and for future expansion. On the previous problem, in case the voltage drop exceeded 3%, let's say 5%. The additional computation is as follows. Since the initial selected wire is number 12 THN, make an one step higher. Adjustment, select initially number 10. Gamitin muli natin yung equation. Then, i-substitute natin yung mga value. Then, sa area, ginamit natin yung circular mill ng number 10. Kaya meron tayong 0.58 volts. Then, divide natin sa maximum voltage ng ating ginamit na solar. Then, times natin sa 100%. Meron tayong 1.79. Mapansin natin mas bababa or less than 3 yung percent. Kaya, number 10 as the final wire to be used in the system. Then next is note K direct current constant. This is constant representing the direct current resistance for 1000 circular mills. Conductors that's 1000 feet long at an operating temperature of 70 degrees Celsius. The direct current constant value you should use for copper is 12.9 ohms. Then sinasabi nga natin na yung K is constant na may value na 12.9. Then next is for solar powered homes, zero bill. Para ma-achieve natin yung zero bill, kailangan natin mag-compute ng ating monthly average ng kilowatt hour. Ang monthly kilowatt hour namin is 72 kilowatt hour per month. Then, convert natin siya sa daily usage na 30 days. Meron tayo ngayon na 2.4 kilowatt per hour per day. Then, convert natin to watt. Kaya meron tayong 2,400 watt per day. Note, in the Philippines, peak sun hours is 5 hours per day. Then, yung Philippines daw ay merong average or merong makukuwang energy from the sun na magagamit for electricity na 5 hours per day lang. Kaya, i-divide natin based on location natin. Then, kaya i-divide natin sa 5, yung nakuha natin na 2,400 na watts per day. Kaya lalabas is 480 watts. Then, for zero bill assurance, we have a certain error. Kaya mag-a-add tayo ng 10%. Natatimes natin siya sa 1.1. Meron tayo ngayon na 5.28 watts. Then, the number of panels, divide natin kung yung power na gagamitin natin na solar na 580 divide 300 is equals to 1.76. Kaya maaari naming magamit na solar panels is 2 panels.
So we have here gagi mali. I am F.R.CAJUCOM and I'm presenting solar panel roof installation. I am F.R.CAJUCOM and I'm presenting solar panel roof installation. So, what is solar panel? solar panels are generally installed on rooftops, building tops, or standalone facilities. It is very important to install your solar panel at location that gets the most direct sun exposure. So bakit nga ba sa sa taas kasi para mas mas makuha yung sikat ng araw kasi the more na nasa taas yung solar panels mo, mas makaka-gain siya ng araw. Like hindi yung nakalilim ka. So, ang mga materials natin dito ay meron tayong grid tie inverter, DC circuit breaker, DC surge protection device, AC circuit breaker, AC surge protection device, time delay switch, DC-AC electrical wires, MC4 connector, solar rail, clamp. So, hindi ko na siya isa-isahin kasi na-discuss na siya last time, but yung idea dito ay makukuha naman natin. Then, what's the ideal route orientation in the Philippines? So since Philippines ay nasa equator, and then the area orientation commonly regarded as the direction which the solar panels face of the areas in the northern hemisphere of the country must be facing the south direction. So tayo nasa equator, and since ganon, so dapat naka-face yung solar panel into south direction. So the net metering, so it allows residential and commercial customers who generate their own electricity from solar power to sell the electricity they are using back into the grid. So yan yung net metering, and beside that, meron ding law about that sa Philippines. Net metering is a non-fiscal incentive provided under Republic Act 9513 or the Renewable Energy Act of 2008, which aims to promote the utilization of renewable energy in the Philippines. Pinoprovide na to yung mga customer na hindi dapat mag-exceed ng 100 kilowatts ng solar power sa kanilang mga bahay or kahit ano pang mga business. Then they can take advantage of the huge benefits granted by our local laws. So sila din yung nagbe-benefit nun dahil din sa law na ginawa nila. So ito yung mga benefits. Most of your power will be generated during peak hours. Peak power consumption period usually run from 9 a.m. to 9 p.m. and reduces electricity bills. Like nakakabawas talaga siya ng electricity bills. Bakit? Kasi yung power na nakukuha na ginagamit mo sa bahay ay galing sa araw. Eliminates the need of batteries. Investing in batteries is very costly and can make the process of setting up your solar system more difficult. So, mas mahirap nga yan. So, yun lang mga benefits, and that's all. Thank you for listening.
So now let's proceed to the second part of our discussion for this video. So we have the solar-powered home, its working principle, how it works in detail, enumerate each part and function, and discuss the law on net metering. So let's proceed. So we have the solar panel, minimum of 1 kilowatt. So overall rating, we have 1 kilowatt solar panel being installed. That solar panel is divided into 3 solar panels. Rating 330 watts per panel, to sum it up with 990 kilowatts or approximately 1 kilowatt solar setup or solar system. And it produces 1.3 unit of electricity per day. To sum it up, we can gather 48 kilowatts per hour in months. So that's the rating of our solar panel with the minimum of 1 kilowatt. Then we have the line-to-line connection. Since the location we are assuming to install the solar panel or photovoltaic solar panel setup is in Cabanatuan City. So Cabanatuan City, the distribution utility here is Celcor. Then let's proceed to the type of solar panel. So we use as our own design the polycrystalline solar panel. It characteristics made it most suitable solar panel to use. So sabi ko nga kanina, when I'm talking about solar panel, it's not polycrystalline, the monocrystalline. So it's some sort of typographical errors. We will use a monocrystalline kasi here in Cabanatuan, we have a high temperature and high humidity, especially ngayong summer, kaya suitable si monocrystalline sa aming own design setup. So ang aming brand of choice, kung kami ay pipili at isa-set up talaga namin to, we will choose the American-made solar panels from LG Solar. Now let's talk about our inverter. Kung anong inverter yung gagamitin namin sa aming own design. So we have the overall rating. Gagamit kami ng isang inverter with the rate for our photovoltaic system 1 kilowatt. So ang rate ng aming AC, ang rate ng AC output niya is around 2 kilowatt to 4.2 kilowatts. That can support around 10 to 20 amperes. Tapos meron siyang direct current na voltage na umaabot sa 600 to 85 volts. At efficiency rating niya is 97.5%. So without limiter na gagamitin namin kasi kung bakit, i-discuss pa siya. Malalaman natin into the further slide. Sa mga susunod na slide. So let's proceed. Ang gagamit namin is pure sine wave kasi most of the appliances today is gumagamit na ng pure sine wave. Our brand of choice is ABB Uno 4.2. So ito yung rating kanina sa overall rating namin. So inulit ko lang siya dito. Now let's proceed to DC and AC circuit breaker. So rating and computation tayo from Ohm's law, the classic Ohm's law. Current is equal to power over voltage, where P is the power and V is the voltage. So ang ating power is 1,000 watts or 1 kilowatt. Then ang ating voltage na sa buong setup is around 220 volts. Then to get the current, we have to divide the power by voltage. So we can get 4.54 amperes. So how it's being connected? So this is our solar inverter. Then the direct current coming from the solar panels is mapupunta sa kanya. Then si inverter ang responsible to for that direct current to become a AC current. Kung ba't siya ililipat sa AC is because direct current is paiba-iba yung kanyang current na dala. So while si alternating current is meron siyang computed na allotted na ibabato sa system natin or sa ating mga bahay para magamit natin siya. So ito, familiar naman tayo sa Ruyo na brand na electrical devices. So ito yung kanyang plug-in. Plug-in yung gagamitin nating breaker kasi yun yung usually nakikita sa mga bahay dito sa Pilipinas. Now let's talk about the surge protection device for AC and DC. So ang rating and computation, AC and DC surge protection device rating must be equal to the total current of the system. Kasi nga si surge protection device is pinoprotektahan yung system natin from the sudden change in current sa ating system. So pagka ang system yung poprotektahan natin or sa system galing from solar panels pupunta sa ating mga appliances, kailangan natin ng surge protection device na ang total current niya is katotal ng system para maiwasan yung sudden loss or sudden increase sa current. So or sa ating power sa bahay. So when it comes to line, it must be the sum of the current line. Kasi nga galing sa line, so kailangan sum nung pinaka total current sa line para pagka bumaba yun or tumaas yun, is magre-react si ating surge power device. So here it is, how it is connected from, tingnan muna natin sa ating system to our house. So we have the solar panel, SDP protection from DC to DC, direct current kasi galing sa solar panel. Then, ililipat naman siya sa SPD AC. Then, yan. Then, pupunta siya sa inverter. So, DC pa rin pala siya, sorry. Pupunta siya sa inverter. Then, dito naman paglabas, AC, then AC, para pupunta pa lang sa ating main switchboard. So, now let's talk about electric wire. So, rating and computation. PB wires and USE-2. Ito yung napili namin gamitin para sa aming Model Y because these wires handle 90 degrees in wet condition and 105 degrees in dry condition. So, dito sa Pilipinas, suitable siya kasi meron lang tayong two climate, the wet and the dry. So, pag wet season, so bumababa ang temperature natin lalo sa mga lugar na nababaha. So, and then, pag dry season naman is masyadong mataas ang ating temperature. So, ito yung wires na pinaka-suitable kung gagawa tayo ng solar power home or PB setup. So, 10 gauge or AWG yung gamit nating size ng ating wire. Then, the zero bill computation for grid-tied solar power on design. So, ang rating natin, to achieve the zero bill, the total usage of electricity per month must be covered the electricity produced by the system. So, how it is? So, ito, the total power that our system or our photovoltaic system can produce per month is isusubtract lang natin sa ating normal usage na galing sa ating distribution utility. So, kapag ang result natin is a negative result or ang negative result yung nakuha natin, hindi tayo nag-a-achieve ng zero bill computation. While pag hindi negative yung ating nakuha is nag-a-achieve tayo ng zero bill computation. And that excess na napoproduce ng ating photovoltaic system is binabato pabalik sa ating grid kasi we're connected to a grid type solar power home. Then, binabato na yun sa grid is pwede pa tayong kumita doon or babayaran tayo ni distribution utility natin kung kanino man tayo naka-connect. So, let's proceed to the roof installation. So, needed part. We have, as said earlier, 3 solar panels, frames and wires, inverter, and the organizing clips for wire. So, ito yung nasa roof installation. Ideal roof orientation in the Philippines. So, since we are above the equator, the area of solar panel must be facing the north. Kasi sa equator, doon nag-uumpisa yung sikat ng araw. So, ito tayo sa Philippines. Then, ito yung equator, north, east, south, west. So, sa south, facing south dapat nakaharap yung ating solar panel. Kasi as the sun strikes or the sun arose in the morning, yun yung unang point na tatamaan niya. Then, pataas, sorry. Okay. Now, let's talk about net metering. So, law in the Philippines, the net metering is the first non-fiscal incentive mechanism fully implemented under the Renewable Energy RA Act of 2018 through the installation of solar photovoltaic panels up to 100 kilowatts. Homes and commercial establishment can now partially satisfy their electricity demand by themselves. So, yun yung law ng net metering sa Pilipinas. So, kagaya nga kanina na sinabi ko, ba't hindi na natin kailangan ng limiter sa ating inverter? Kasi nga, yung limiter, ang function niya is to calculate kung ano yung binabato natin sa grid at kung ano yung binabato natin sa grid para mabayaran tayo, para hindi mas lumaki yung bill natin or consumption natin ng electricity. So, si net metering is a law created to protect that certain happenings or that certain scenario na kung kailan tayo nag-set up ng solar power home or PV setup is tsaka pa lumaki yung ating electricity. So, yun yung isang scenario na iniingatan ng ating ng net metering. So, benefits, ano ba yung mga benefits ng net metering sa atin as consumer? Net metering allowed customer of distribution utility, DUs, to install on-site renewable energy facility not exceeding 100 kilowatts in capacity so they can generate electricity on their own use. So ito yon, again ang sinasabi ko kanina, poprotektahan tayo nito para magbayad pa. Kasi halimbawa, ang consumption lang natin is per month, kunyari, is 50 kilowatts. Then naka-install tayo naka-install tayo ng PV na 100 kilowatts as yun yung hanggang doon lang yung limit na pwede nating install. Then the rest 50 watts is babato sa ating distribution utility. Net metering is the law protecting that to happen na hindi tayo magbabayad ng another 50 na tayo yung babayaran ni distribution utility ng another 50 for that certain type of electricity na binabato natin sa grid. So that's the end of our part 2. Thank you for listening.